Okay, so as I said on today, we're going to be talking about, today we're going to be talking about distance and displacement and the difference between the two. So let me get ready to share my screen and show you guys what's going to be in Schoology. So this is 8th period. And if you go to the folder for today, you are going to see several items. And so today's Tuesday. Today we're going to be going over this PowerPoint, which explains the difference between distance and displacement. Then I'm going to, go over this PDF worksheet with you guys, and we're going to go over this as a class and kind of discuss things here. And then hopefully, if you have an understanding of the worksheet, hopefully you guys will be ready and prepared to do the distance and displacement assignment that I am going to make available in Schoology as soon as we are done with this Zoom call. Okay, and it's it's assignment. I think it's like 15 questions, all multiple choice, 10 or 15 questions, somewhere around there. So that's the goal for today. Today is going to be a pretty straightforward day. Okay, let me get ready to pull up the PowerPoint. Now let me share my screen with you guys again. Okay, and guys, give me a second while I get logged on my other computer. That way I can see the chat while I'm teaching. Give me just a second. Okay, so let's go ahead and start this PowerPoint here. Okay, so these two terms, distance and displacement, these are terms that you guys have heard me mention a lot this year. I've used these terms for the most part. It appears as if I use these terms interchangeably, distance and displacement. And when most people think of these terms, they do think that they can be used interchangeably. However, there's a slight difference between the two terms. Just like there was a difference between speed and velocity, there's a difference between distance and displacement in terms of how physicists refer to them. Remember, both speed and velocity, both of those mean how fast an object is traveling, but velocity specifically means how fast an object is traveling in a particular direction. So whenever you're talking about velocity, you are concerned with direction. Whenever you're talking about speed, you're not concerned with direction. You can basically just, speed doesn't concern itself with direction. Speed is always a positive value, but with velocity, because velocity concerns itself with direction, velocity can be positive or negative. Okay, so with that said, let us talk about distance and displacement. Distance, by definition, is defined as the total ground an object covers over the course of its entire trip. Displacement, on the other hand, refers to how far out of place an object is from its starting point. Displacement also includes the object's direction relative to its starting point. So I'm going to highlight that there because that's important. That's pretty important that you guys know that displacement includes direction. Okay, so basically displacement can either be positive or negative. Distance, on the other hand, whenever we're talking about distance, we're not concerning ourselves with direction, but with displacement, we do concern ourselves with direction. Okay, so I'm going to read this definition again. So distance is defined as the total ground, I'm going to emphasize that, the total ground an object covers over the course of its entire trip. But displacement refers to how far out of place an object is relative to its starting position. So in order to make sense of these definitions, let's just do some examples. Okay, so let me ask you guys a question. Well, you know what? Let me back up. Before I ask you guys a question, let me draw my grid first, just to kind of, put some things into perspective. Imagine that I'm able to walk on this grid here. So I'm able to walk on this grid here. And so imagine that, wrong color. Imagine that I'm able to start here at this point right here on this grid. Okay. And as I start at this point, imagine that I was to walk 6 meters to the east, briefly come to a stop here, and then I walk 2 meters toward the west. And then here I permanently come to a stop. Here. So, can someone tell me what was my overall distance? So I went 6 meters to the east and I walked 2 meters to the west. Anyone want to tell me what is my overall distance?
4.
No, my overall distance. Remember, distance represents the total ground that I covered. Anyone?
8.
Exactly. 8 meters. So 8 meters was my distance. But can someone tell me what is my displacement? Could someone put the link to the attendance form in the chat box for Caden? Thank you, Emily.
Isn't the displacement 6?
No, the displacement is not 6. Remember, displacement means how far I'm out of place from my starting point. So what is the distance between the starting point and the ending point?
4.
4. Thank you, Alexa. Was that you, Alexa?
Yeah, that was me.
All right, thank you. 4 meters. Specifically, guys, 4 meters to the east. So, guys, whenever we're talking about displacement, we have to also include direction as well. Okay, because if you guys notice, displacement represents it basically displacement represents the exact distance between the starting point and the ending point. And notice my ending point was to the east of my starting point, so that's why I say that my displacement is 4 meters to the east. Okay. So hopefully everybody should see the difference between distance and displacement. Distance represents the total ground I covered. And so notice I walked a total of 6 meters. I'm sorry, of 8 meters, because 6 plus 2 is equal to 8. Okay. But notice what my displacement is. If I had to just solely focus on the distance between my ending point and my starting point, that would be 4 meters. Okay. Let us do another example. Okay, let me see. Where do I want to start writing? Okay. So if I start here, someone tell me if I walk what do I want to do? Someone tell me if I walk 5 meters to the east, briefly come to a stop, and then I walk 4 meters to the west here, and then here I permanently come to a stop. Can anyone tell me what is my distance and what is my displacement? So I walk 5 meters east, 4 meters to the west. Oh crap, what just happened? Oh, there we go. So anyone have an idea?
Is the distance 9?
Yep, exactly. The distance is 9 meters.
And the displacement is 1.
Yes, 1 meter to the what, Alex? What is my direction, Alexa?
Displacement 1.
Yeah, 1 meter to the what though? Because remember,
Oh, to the east.
to the east, exactly. So you're exactly right. So 9 meters is your distance, and your displacement is 1 meter east. Okay. So hopefully you guys get the idea. The total ground that I covered is 9 meters, and the displacement, I'm 1 meter away from there's a 1 meter difference between my starting point and my ending point. And so my displacement, and of course my ending point is to the east of my starting point. Consider this example right here, guys. What if I have something like this? What if I start up here, and let's say I walk 5 meters down south, briefly come to a stop, and I walk 2 meters north. And then here I permanently come to a stop. Okay, so I went 5 meters south, then I walk 2 meters up north, and there I permanently come to a stop there. What is my distance and what is my displacement?
Distance is 7 meters, and the displacement 3 meters south.
Yeah, exactly. Exactly. So yeah, my distance is 7 meters. And you're right, my displacement is 3 meters south. Exactly. And we know it's south because notice that red dot is to the south of the green dot. So the total ground that I covered was 7 meters. The total ground that I covered was 7 meters. But how far am I out of place from my starting point? Well, there's 3 meters between this point and that point. And notice this dot here, my ending point is to the south of my starting point. So that's why I say 3 meters south is my displacement. Okay. Hey guys, I'm gonna do one more on the PowerPoint before we get to that PDF worksheet. One more. Oh, excuse me. Okay, so let us imagine that I start right here. Okay, so one more example. So let us imagine that I walk 7 meters to the west. So, okay, so if I walk 7 meters to the west, briefly come to a stop here, and then from there I walk 3 meters to the east, and here I permanently come to a stop. Okay, so I went 7 meters west, and then I went 2 meters east, and then there I come to a stop. What is my distance? The overall ground covered.
9 meters.
It's not 9.
Oh,
10.
10 meters.
Yeah, 10 meters exactly. So my distance is 10 meters, right? Because 7 plus 3 is 10. And what is my displacement?
4 meters west.
Exactly. Thank you, Isaiah. 4 meters west. Right, because my displacement is basically the shortest distance between my starting point and my ending point. And if you notice, the ending point is to the west of my starting point. Okay, so it's 4 meters to the west. Okay, I think that makes sense to you guys. So let us now work on this PDF worksheet that I have in Schoology. Okay, guys, give me just a second while I upload this worksheet into Kami. And then I'll be ready to share my screen with you all. Okay, so guys, during a normal school year, as soon as we're done introducing distance and displacement, I will give this worksheet to my students and we'll basically have them work this out in class. But obviously, this is not a normal school year where we are learning virtually. So what we're going to do, we're going to um, go through these instructions together, fill this out, and then fill out the answers here at the bottom. And hopefully, by the time we're done with this, everybody will have an excellent understanding on distance and displacement so that you guys will be ready to do the assignment that I have posted in Schoology, or that I'm going to make available to you guys as soon as we're done with this Zoom call. Okay, so so here are the instructions for this worksheet. Basically, there are 4 main steps you have to follow to be able to work through this worksheet here and fill out the bottom here. Okay, so let's get started. And again, you guys help me out as I walk through this. Okay, so if you look at step 1, step 1 says measure a distance of 10 centimeters straight east and mark it as point A. Write down the distance for leg 1 and then measure and write down the displacement. So here's what we're going to do. Okay, so notice it says go 10 centimeters straight east. That's the first step. So this is where we're starting from here, because notice it's labeled home. So we're starting from this point right here, and we're going to draw a line 10 centimeters straight east. Now someone tell me, if each square is half a centimeter, right? So each square is 0.5 centimeters, then how many squares do we need to move in this direction to get a total of 10 centimeters? What do y'all think?
20 squares.
Exactly, 20 squares. So I'm going to start here, and I'm going to count a total of 20 squares towards the east. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay. So that's 20 squares. Let me count that one more time just to make sure this I didn't go over. Huh? Looks like I'm short one. That's weird. Let me count this one more time. Just make sure 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Yeah, I'm short one. It's a good thing I counted it. Okay, so let me draw one more line to represent 20. Okay, so there we go. Okay, so that line is 10 centimeters. Okay, and of course the instructions. Okay, so we want to label that point A. So I'm going to label this point right here, point A. And of course, I'm going to call this line here leg 1, because we're at leg 1 of our journey. So leg 1. Now, let us begin filling out this bottom here. And this first leg is pretty easy. Well, what is the overall length of leg 1? In other words, what is the distance of leg 1 from here to here? It's obvious. It's just 10 centimeters. What is the total distance we've traveled since we walked from home? This is still obvious. We walked a total of 10 centimeters. So the total ground we covered is 10 centimeters so far. And then what is our overall displacement? 10 centimeters toward the east. Okay, because that's our displacement. Our displacement, remember, in this case, our stopping point is to the east of our starting point. Okay, so that was pretty much all we had to do for step 1. Okay, let's keep going to step 2. Okay, So step 2 here says measure a distance of 10 centimeters straight north and mark it as point B. Then write down the distance for leg 2, write down the total distance traveled from home, and then write down and measure and write down the displacement. Okay, so let us do step 2. Okay, so here, now in this step right here, it told us to go 20 centimeters straight north. So that's what I'm going to do here. I'm going to go 20 centimeters straight north. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16, 17, 18, 19. Oh, crap. I lost. I'm sorry, guys. I didn't mean to do that. Let me. Okay, let's do this again. That wasn't supposed to happen. Okay, so 10 centimeters straight north. That's 10. I'm sorry. That's 20 blocks. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then 16, 17, 18, 19, 20. Okay, there we go. So we're going to mark that. We're going to mark this point B. And this right here represents leg 2 of our journey. Okay. So, okay. So, guys, with that said, let us answer these questions. Well, not answer these questions, but let us fill in these blanks here. So, leg 2 has a length of 10 centimeters. That's the distance of leg 2. Someone tell me, so far, what is the total distance we walked since we began at our home spot? What is the total?
20 centimeters?
Yes, exactly. 20 centimeters is the total distance. All right, so we walked a total of 20 centimeters. But someone tell me, what is our displacement? Now, this is tricky for a lot of students here. How do we find the displacement between this point and that point? What do y'all think?
We use a 2D vector.
Um, so well, we're not thinking about vectors yet, Isaiah. But let me ask you a question. If
Pythagorean theorem.
There you go. That's exactly what I'm looking for. Did everybody hear Alexa? You're going to use Pythagorean's theorem to find the length between this point and that point. Exactly. Isaiah, you got that?
Yes.
And of course, Isaiah, I mean, technically you were right. If we were talking about vectors, you could use Pythagorean's theorem to find the magnitude of a vector. Isaiah, how do you know about vectors? When have you because I haven't taught that yet.
I looked up some from Khan Academy.
Oh, really? Oh, okay, nice. Yeah, we're gonna talk about vectors in the coming weeks. So you're kind of getting a little ahead of me, but that's good. That's a good thing.
Thanks.
Okay, so where am I? Okay, yeah. So guys, we're gonna use Pythagorean's theorem. And guys, what is Pythagorean's theorem?
A squared plus B squared equals C squared.
Exactly. Was that you, Devin?
Yes.
All right, thank you. A squared plus B squared equals C squared. So, so using Pythagorean's theorem is going to allow us to solve for the length of this line here in blue because that's going to tell us our displacement. So leg 1 is 10 centimeters. So I'm going to plug in 10 there. Okay, leg 2 is also 10 centimeters, and I want to plug in 10 centimeters there. And of course, we're looking for our hypotenuse, which is C, so I'm going to leave that as it is. So 10 squared is obviously 100. So 100 plus 100 is equal to C squared. Okay, and obviously 100 plus 100 is 200. And then we got to take the square root of 200 to get C. So everybody follow me what I did? Just,
Yeah.
all right. So just simple algebra. 100 plus 200, 100 plus 100 is equal to 200. So the square root of 200 is 14.14 when I put it in my calculator. So when I go up here, that means my displacement here is 14.14 centimeters. And of course, that's to the northeast. And hopefully it should be obvious to everybody why that's to the northeast is because if you notice, my ending point here is to the northeast of my starting point. Make sense, guys? So my displacement is 14.14 to the northeast. Let me zoom out so you guys can kind of get a screenshot of that if y'all want that before I erase it. Okay. All right, we're almost done here, guys. We got to finish step 3 and step 4. Let me go ahead and delete this so I can have some room to write. And why aren't you deleting? Okay. All right, so let's move on to the third step. So the third step says measure a distance of 10 centimeters straight west and mark it as point C. And so write down the distance for leg 3, write down the total distance traveled from home, and then measure and write down the displacement. So let's go into this. So now at this point right here, we're going to go 10 centimeters straight west. So that's what step 3 is. So let's do that. So let's go. So from this point right here, we go to, hold on, guys. So we go 10 centimeters straight west, which is 20 squares. So I want to go 20 squares. Okay, let me make sure is that lined up right there. Yeah, looks pretty good. Okay, so we're going to mark this point right here. We're going to mark this point C, and we're going to call this leg 3. Okay. And the length of leg 3, in other words, the distance of leg 3, is just 10 centimeters. Someone tell me, what is the total distance we traveled since we started our journey? Yep, 30 centimeters. But what is our displacement? I want you all to tell me, what is our displacement here? So you guys tell me. So looking at this point right here, relative to our initial point, what is our displacement?
10 centimeters north.
Exactly. 10 centimeters north is our displacement, right? Because displacement just represents the shortest line possible between your starting point and your ending point. So 10 centimeters north is my displacement. Okay. And hopefully that should make sense to everyone. Because notice my ending point here is to the north of my starting point. And to be specific, it's 10 centimeters to the north of my starting point. Excuse me. Okay, so let us finish this off. So step 4 says measure a distance of 10 centimeters straight south. Write down the distance for leg 4. Write down the total distance traveled from home, and measure and write down the displacement. So here from this point we're going to go 10 centimeters straight south. So I'm going to basically connect these 2 points here. And I'm going to call this leg 4. So I'm going to call this end right here leg 4. 8 and yeah, so we went 10 centimeters straight south. Okay. Now, the length of leg 4, in other words, the distance of leg 4, is obviously just 10 centimeters. Okay. Now, someone tell me, what is the total distance we traveled since we started from our initial point? We went here, 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 and
40
here.
meters.
40,
Centimeters.
40 centimeters. Yes, thank you, Amaya. 40 centimeters. Okay. But guys, what is our displacement? Anyone know?
0.
0, exactly, because we came back home. We're back at our starting point. So our displacement is now 0. Okay. Guys, anytime you come back to your starting point, your displacement is always 0. So if you go all the way around, you come back to your starting point, like you're no longer displaced from your starting point. You're back at your starting point. So your displacement is 0. Okay. Any questions here? Any questions on what we did? Hopefully that makes sense. Before I let you guys go, I want to say something. Guys, depending on the assignment, they may use different conventions for direction. Sometimes you will see direction um, listed out here in the standard directional convention, basically just using north, south, east, and west. But guys, in some assignments, they could also use positive and negative to indicate direction. In fact, the assignment that I'm going to post in Schoology will use positives and negatives to indicate direction. Basically, guys, the general convention applies. Anything that's going north is positive. Anything that's going south is negative. Anything that's going east is positive. Anything going west is negative, right? So same thing if you were going up, down, right or left. Basically same convention. So with that said, guys, so if something has a displacement that is 10 centimeters to the east, basically you would say that's a positive displacement. So you could also write that like this. So positive displacement. Same thing if something has a displacement that says 10 centimeters toward the north. That is also a positive displacement. But guys, what if you see something that says 10 centimeters toward the west? What type of displacement is that? A negative displacement. So y'all got it? So hopefully that makes sense. And remember, guys, whenever you're looking at displacement, you're always comparing your ending point to your starting point. So wherever your ending point is relative to your starting point, that's your displacement. If your ending point is to the south of your starting point, then you would say your displacement, your displacement is to the south. So just keep that in mind. Okay, any questions, guys? Any immediate questions for me? And again, this worksheet is in Schoology along with the instructions in case you guys want to go back and look over everything. This video will be posted in this video will be posted on my YouTube page. Let me see what else. I think there was something else I want to say. No, I think I'm good. So if you guys don't have any immediate questions for me, you guys are free to go. I'm gonna have the assignment in School G in about like 5 minutes or so. It's gonna be posted. Hope you guys have a good day, okay?